Okay, these are problems 21, 22, 23, 24, test for review, and this is about scientific notation. Problem 22 and 4 are sort of opposites of each other, and problems 21 and 23 are opposites of each other. So we're going to take a look at how to work these out. First, as a general rule, when you have scientific notation, any numbers that you have that are not in scientific notation but in standard form, these are all in standard form, these are in scientific notation format. Your objective is always to get this decimal, no matter what kind of number it is, so that it's resting between the numbers. In this case, if it's 654, you want to make it the smallest whole number that you can. So that puts the 6 in the ones place if you put a decimal there. In this situation, it's the same thing. You want to put the decimal so that the number ends up in the ones place. So in this situation, you're going to put the decimal between 4 and 5, so the number 4 is in the ones place. You'll put the decimal between the 7 and the 8 because the number 7 will be in the ones place. Okay, that's just sort of a bigger picture idea. Now let's go through the steps. For this problem, 21, you want the decimal to be between the 4 and the 6. So we're going to move that decimal 2 places. And this is important to count the number of places. 2 places to the left. So when we move left, we're making a positive exponent. So that will change our number because we move the decimal 2 places to 4.62. The 94 is still there, and we moved it to the left, so it's a positive exponent 2 places. So it's a 2 for the exponent. 4.6294 times 10 to the second. When we undo it, we go the opposite direction. We'll move that back 2 places because it tells us to go 2 places. And we'll have our number back of 462.94. Okay? This is the answer, however, right here. We now put our number 462.94 into scientific notation of 4.6294 times 10 to the second. In this situation, problem 22, we are trying to do the same thing where the destination is get that decimal between the 7 and the 5, so the 7's in the ones place. So when we do that, we have to count how many places we're moving. 1, 2, 3, 4. We're going to move 4 places over. 1, 2, 3, 4. In this situation, we're going to be moving to the right, and that means our exponent will be negative. Anytime you have a very, very small number, you'll have a negative exponent. A very small number that is with zeros in the front and there's a decimal. So let's continue. We move 4 places to the right. 1, 2, 3, 4. So we rewrite our number as 7.54 times, and we moved to the right direction, 10 to the negative 4. I should probably put here we move 2 places left, and here we moved 4 places to the right. And again, this is your answer, and remember you can put it back whenever you have a negative. You move the decimals to make the number smaller, and if we moved it 4 places over, we would get back our number. Okay, so for these, We have 10 to the 5th, which tells us we're going to move the decimal 5 places. To the right. Notice these are opposite. This direction we move 2 places left to give our positive exponent. When we have a positive exponent already, we go 4 places right, the other direction. So we're going to go 1, 2, 3, 4. Uh-oh, we need another spot. We can move, but we have to add a 0. So we will have 5, 1, 2, 3, 4, and the 5th move, to move 5 places, you have to add a 0. So that puts the decimal here. It traveled from in between these numbers to 1, 2, 3, 4, 5, right to there. And that gives us, we took off this whole times 10 to the 5th. So our number, remember your rules about commas, the comma will go here every 3 spaces. We have a new number of 518,150. Alright, in this situation we have a -6, so we do the opposite that we did up here, which is we're going to move this decimal now 6 places to the left. Whenever you have a -6, you know you're going to have lots of zeros in front of your number. So in order to move 6 places left, let's retype the number so we can do that a little easier. So what we're going to do is this decimal is going to move 1, 2, 3, 4, 5, 6. So every time we have one of these little loops, we put a 0. 1, 2, 3, 4, and it's going to be 5 zeros because the first move was across the bottom of the 3. So we'll look at that again. 1, 2, 3, 4, 5, 6. It puts 5 zeros in front of the number. So in the end, our number now looks like point. You can do the decimal or you can do 0 point. This 0 here does not mean anything. So we have 1, 2, 3, 4, 5, 3, 5, 8, 7. That's what our number looks like when we're done. So in standard form, this exponent becomes this. In standard form, this exponent becomes that. So remember how to go back and forth. This is positive exponents, and these two have to do with negative exponents. And the major difference, when you have a negative exponent, you're dealing with numbers that have zeros in front. And with the positive, you're dealing with numbers that have zeros on the other side, or no zeros at all, they're just digits. Okay.